Hello friends, welcome to the Oncoscholar channel. In the last video, we have covered basic ideas about survival analysis, or we can say time to event analysis. So last video में हमने cover किया था data structure for survival analysis, clinical scenarios जहाँ हम survival analysis perform करते हैं, हम data कैसे manage करते हैं. So आज के वीडियो में हम आगे बढ़ेंगे और देखेंगे कि हाउ वी कैन परफॉर्म सर्वाइवल एनालिसिस बेस्ड ऑन म्यूटेशन ऑफ अ पर्टिकुलर जीन इन एनी पर्टिकुलर कैंसर using the TCGA datasets. So along with that we will cover basics of Kaplan Mir plot also. So survival analysis basically दो तरीके से करते हैं. फर्स्ट वेरी कॉमन मेथड इज़ मेकिंग प्लॉट्स ऑफ सर्वाइवल दैट इज़ कॉल्ड Kaplan Mir plots. So Kaplan Mir plots almost always they are used for clinical studies. So आज हम कवर करते हैं KM plots for the TCGA cancer patients. So I'm going to cBioPortal and I am accessing let's say low grade glioma. So I'm just going for the brain. So glioma mein there are commonly two categories. One is low grade glioma and the second one is glioblastoma. So ये दोनों जो categories है, जो दोनों cancer types है, they widely differ in their survival, but both of them are altogether called as glioma. One of the reason they are studied differently because the survival in these two tumors are actually very much different. Glioblastoma is like most aggressive kind of glioma, you can say late stage glioma. So we can see this thing. So let's say if you search for the brain cancers, you see there are some low grade glioma and you see also glioblastoma. So let's just see इनका data क्या क्या available है cBioPortal पर. So I'm just starting with low grade glioma, or I'm selecting the pan cancer study. So this is the pan cancer study for low grade glioma, and you can already see there are survival plots here. So you see on these four survival plots, these are KM plots for different type of survival assessment. So starting with overall survival, disease-free survival, disease-specific survival, and progression-free interval. So I will cover what are these different types of survival in my later videos, but for today you just see what can be the scenarios, and you can clearly see ये survival जो parameters हैं इसमें if you see on the x-axis there are number of days, on the y-axis there are a fraction of people which are still surviving. So you see the timelines of these different analysis are also very different. Let's say for the disease free it has hardly gone to like 150 days and in overall survival 200 days. So this may also differ, but we will cover up those points in the later on. So this is basically a brain low grade glioma. But if you see the GBM glioblastoma, which is the most aggressive kind of glioma, so we will just take the GBM study. So in this you can clearly see it is clearly very different from the low-grade glioma in which you had survival parameter, all 4 survival parameters with the different timeline of like 200 days and beyond. But if you see in the aggressive glioblastoma, the timeline has not gone up to that point because the survival is so poor that you cannot follow the patient for more. Most of the patient die within a few months from diagnosis. So these are the features which we usually assess with the survival analysis and the commonly by the KM plot. So आज वीडियो में हम कवर करते हैं let's say a common mutation which is used as a biomarker for patient survival in low-grade glioma. So one of that feature is IDH1 mutation. So IDH1 is a gene involved in multiple cellular pathways, and this is now an established marker in glioma. So I'm just searching for IDH1 in the brain low-grade glioma data set. So let's see how much percentage of patients have mutations. You see 77% of patients have alteration in the IDH1 gene, specifically in this TCGA low-grade glioma dataset. And let's see what happens with the patient having this mutation, whether they are there is any difference in the survival. So let's just compare these two groups, one group having the mutation and the other group which doesn't have the mutation. So survival comparison, you can see all 4 different type of analysis and a clear difference between altered group and unaltered group. So altered group are IDH1 mutated patients, and unaltered group is IDH1 wild type patients, and you can clearly see that the patients having this alteration, they actually respond much better. They have a much more longer average survival. So IDH1 mutation is actually a good indicator in terms of patient prognosis. So ऐसे बहुत सारी mutations हो सकती हैं जो कि better prognosis से related हों. ऐसे ही बहुत सारी mutations we already know on which let's say oncogenes. So proto-oncogene, when they get mutated, they become oncogenes, and unki presence are usually associated with poor prognosis. So there can be different scenarios, but IDH1 is an established marker, and we know that patient jinme IDH1 mutation hoga, so they will survive better than the patient which don't have it. And you see on the left there are different type of survival analysis: disease specific, overall, progression free and disease free, and you can see these p values, number of patients. So हो सकता है कि किसी analysis में number of patients अलग हों compared to the other analysis. So that is also a thing to consider, that depending upon what is the criteria which we are considering, so number of patient might differ even within the same study. So I'll just cover up a few points about how to interpret KM plots. Iski background statistics ke liye I would say we can just explore it in a little more detail before making any final interpretation of our own data, but let's just cover very few points. So this is a KM plot. On the x-axis you see the number of days, on the y-axis you see the probability of overall survival, or the percentage of patients which are surviving, let's say. But that percentage is not from the total percentage, like 513 if you are seeing this analysis. So it is not the total percentage, it is percentage at different time intervals. So that's why it is written probability. Ab ye exactly kya issue hai? So let's just zoom in to a initial part of the analysis. You see there are different steps going down gradually, and even in this one you can't see much because there are lesser steps. So now you see there are two groups, one is altered, one is unaltered. So the survival fraction, you can clearly see there is a very clear difference. And how do you statistically measure this difference is by giving this p-value. Now p-value here, what you can see, it is written log rank test. So दो तरीके के स्टैट्स यहाँ पर कॉमनली यूज़ किए जाते हैं. वन इज़ द लॉग रैंक टेस्ट, so which only gives you a p-value. So p-value, if you know it is less than 0.05, it is considered as a significant difference. But many of the times you might see a hazard ratio also. So hazard ratio are not usually from the log rank test, because log rank test only gives you a p-value suggesting there is a difference between survival. So now you are very sure that survival दोनों groups में differ करता है. But how much is the effect, how much it is differing? So that only that you can get only by the hazard, if you have the hazard ratio. And for hazard ratio, people usually do a Cox regression analysis, which I will cover up in my later videos. But for today, let's just go with this log rank test. So it is very significant. But how do we exactly interpret? So not going very detailed into the statistics, you see there is a gradual drop at several points of time, and on the bottom you can see these numbers. These are the numbers at risk. So ये basically क्या denote करते हैं? When the study started, when you started the analysis, so at the very beginning there were like two groups, one having 394 patients, the other one having 119 patients. So after this you monitored the patients for some interval, and let's say at 2 months, it can be like less than 2 months, and you see some patient might die in any of the group. So आप देख सकते हैं कि in the altered group there are not much events, there are not many deaths, but in the unaltered group you can see at several points there are gradual dips, and you can even see at which time points these dips are. So these dips actually denotes deaths. So when any dip occurs, it means some death events have occurred. But it is not like not all dips, this dips doesn't actually mean one patient has died. Actually it is the percentage of the patients which were available to be analyzed at the previous time point. So you see from this time point there's a straight line. So let's say these many patients were surviving, let's say 87 patients were surviving at this time. So 87 patients surviving, and then there's a drop, and there are actually two drops, but we can clearly see, let's say there's a drop, and at this drop out of 87, now it is like 85, so 2 patients have died. So the percentage overall probability of survival has reduced, and now at the next time point there are lesser patients to be analyzed. So uske at the next step, let's say 10 patients die, so the percentage of drop will change. So eventually in the later part of the graph you will see even let's say these 8 patients, so even single death event will change the amount of drop you can see, because total patients are 8. Even if 2 patients even if 2 patients die, this graph will come from let's say 40% to let's say 30%, 10% of death, because the total number of patients are differing. So So one of the reason Kaplan Mir survival is so famous, that it covers almost the entire patient data. In the previous video I have covered, like, not all the patients will be having the data for the entire duration. One simple reason, many patients die. The second reason, study में जो patients enroll होंगे, they might be enrolled in later time point of the study, so you might not be having the entire long duration data of the patient. But let's say if you have a patient for which enrolled earlier, so, and you know that patient within this group, let's say without the mutation, it goes up very clearly, it survives up to 6 months. So you can extrapolate the data for a patient which came later into the study, so you can extrapolate the observation for that. So that also get covered up in the Kaplan Mir survival analysis. So clearly you can see that the survival plot summary, you can see the median survival months, those are very much different in the altered and the unaltered group. So these are some of the parameters you will commonly see in the Kaplan Mir survival analysis. Now, along with this, I would say it is not always the mutation which you analyze, because for the mutation, you always have this positive or negative data. Either the mutation is present or absent. So making two groups is always very easy for the mutation related analysis. So you can just clearly make two groups. But in case of, let's say, gene expression, it is not the same. So I will cover up the analysis based on gene expression in any of these patient data sets. So that's all for today. Thank you.